Okay, guys, section 9.42 in section part B in our notes. So what we're going to be doing is we're going to be able to write equations for the sine and cosine functions in this form. So a little bit of what we're going to be doing today is we're going to be given some information and we have to come up with the equation for it. We're going to do that today and then we're going to do it again tomorrow. Today will be a little bit easier because we're just going to be looking at situations where they tell us the rules rather than like writing out the points, which is what we're going to have tomorrow. So let's take a look at this first one. So it's saying that we start off with this function f of x equals 6 cosine x. We're going to translate this 3 units down and pi units to the left. Okay, we did this earlier in the year with parabolas and absolute values, but we've never done it with trig functions. Does anybody have an idea of what our first step would be? And we'll call this, well, they want us to call it G, so let's call this Y1, like our first step. So if I just want to go 3 units down, what am I going to do to this function? Okay. So should it be like cosine and then in parentheses x minus 3, or just an x and then the minus 3? Yeah. So we want the minus 3 not to be with the x. And if it's written like this, it is not with the x. Okay, then the second thing we want to have happen, that was the first thing, is we want to go pi units to the left. Does anybody remember how we make a function move right or left? Good. So I'm going to do 6 cosine, and then wherever I have this x, in parentheses, I'm going to have to do x plus pi. When it's with the x, it's the opposite of what you would think. So to go left, you would think it should be x minus pi, but it's actually x plus pi. And then we still have the minus 3. And I do need to call this g. It tells me to call it g, so I'm just going to rewrite it. And now I want to remind you of how you can use your calculator to check this and see if it looks good. So what I'm going to do is, in y sub 1, I'm just going to put in 6 cosine x. And then in y sub 2, I'm going to put in 6 cosine, oops, don't need that, x plus pi, and then minus 3. And I'm going to see if what I wanted to have happen did indeed happen. So go ahead and push graph. Now remember, if I really want to see that top and bottom, what I can do is I can change my window. So I'm going to change my window so that I have a y minimum of like -8 and 8. That's going to allow me to see the graph better. So there's the first function. We wanted it to go to the left pi. So you can see that it did go to the left pi units, and then we also wanted it to go down 3. And so we can see that that is correct. Any questions? All right, let's go to the next one. All right, so on the next one it says we've got this function. We want to translate it 1 unit up, first of all. So to do that, think about what we would need to do first. What are we going to do, you guys? Plus 1. That's our first step. Then it says followed by a reflection in the line y equals 1. So since we took this up 1 unit, there's something that I can do so that I have a reflection in the line y equals 1. And we may not get this right at first. We're going to check it on the calculator. But what do you think we might want to do? How do we do a reflection? Usually just over the x-axis, because the line y equals 1 is parallel to the x-axis. So how do we do a reflection over the x-axis? Okay, so there's 2 options here, guys. Here's what's going to work. Either we just put a negative out here in front, or we should have multiplied the entire thing by -1. We're going to see if this works. We know it has to be one or the other. So let's put it in. Okay, so there's our original. Okay, so let's take a look now. Oops, sorry, that's not our original. Hold on. I'm going to do a zoom trig just to make sure my window's right. Here's the original function. And here's the new one. And I'm going to go ahead and put in the line y equals 1 because it says we want it to be a reflection over that line y equals 1. So if this was our original function and we shifted it up 1 unit and then we wanted it reflected over that line y equals 1, is that what happened? You guys, some people are saying no. You don't think it's a reflection? But look at this one. This one goes on, up, on, down, on. This one goes on, down, on, up, on. So wasn't it a reflection over this line y equals 1? Yeah, it was. That's all we had to do. Now the other option, guys, was that we could have multiplied the whole thing by a negative. But what that does is that reflects the entire thing over the x-axis. Watch how different this is going to look. Here's our original function again. Here's the new function. And then they're going to put in the line y equals 1. Is that a reflection over the line y equals 1? No, that was a complete reflection over the x-axis after we did. So what that one did was it shifted it up 1 unit, then it reflected the entire thing over the x-axis. So what we had was correct. And that's the way you should do these kind of things, guys. If you're not sure of what to do, check it out on your calculator. So here's the correct answer. Before we go any further, I wanted to talk about something that was on the homework. Like they would give you a function, maybe something like this. And then ask you if it was like periodic. Remember those problems at the beginning? The definition of periodic is that we have the same graph repeating itself over and over and over. Now this isn't perfect because I just, freehanded it. But can you see how this function is following this pattern? And then we have it going in that same pattern. So how long is it taking for it to repeat that pattern again? 4 units, okay? So the period would be 4. So I would say, yes, this is periodic, saying that this is exactly the same shape as that. Like I said, it's not perfect because I drew it, but you get the idea. Like anything that's periodic, it's just the same shape over and over and over. All right, guys. So graphing when we have a lot of stuff going on. We're going to make a chart using our 5 key points. The angle values are going to be changed by horizontal stretches and shrinks, then horizontal shifts left and right. We're going to change the chart values accordingly. This is when we have anything affecting the x. The y values are changed by a vertical stretch or shrink, then a shift up or down. Change the chart values accordingly. Remember that the amplitude is just this a value. The period is always going to be 2 pi divided by b. It's going to be a horizontal stretch. Or we could have, I'm not sure what that's supposed to be saying. Anyway, we're going to have a midline, and that's going to be the horizontal line y equals k. So whatever number we have right here, that's going to be our midline. Okay, let's look at this problem. So we're going to make our chart. See, this is going to have everything happening now. We're going to have changes to the period, changes to, we're going to have horizontal shifts left and right, changes to the amplitude, everything. So I'm going to make an XY chart. All right, so what do we always use 0, pi over 2, pi, 3 pi over 2, and 2 pi. What do the y values, what are they normally for sine?
0, 1, 0, -1.
Great. Okay, we can either see what affects the y's first or the x's. The y's are typically easier for people, so let's go ahead and do the y's first. This 3 is going to cause us to have a vertical stretch. So what am I going to do to all the y values first? Multiply them by 3. And that's because in order of operations, multiplication happens first. Then this is going to affect us. In what way? It's going to shift us what? Down 1. So I'm going to subtract 1. Okay, so these are going to be my y value 5 key points. I have taken care of this, and I've taken care of this. Now I have to look at this multiplier here. This is going to cause us to have what when I have that in front of the x? A horizontal shrink of what? 1/2. So what I'm going to want to do first is I'm going to take that horizontal shrink into effect. So I'm going to multiply everything by 1/2. And that's because multiplication happens first. Okay. So I took care of this. Now I take care of this. What is this going to do? Shift everything to the what? Left by pi over 2. So now I'm going to have to subtract pi over 2 from everything. What's pi over 4 minus pi over 2? What's 1/4 minus 1/2? Negative 1/4. Pi over 2 minus pi over 2 is what? 0. 3 pi over 4 minus pi over 2 is going to be pi over 4. And pi minus pi over 2 is going to be pi over 2. All right, so my graph is going to start at negative pi over 2, which is right here. I'm going to go down 1. At negative pi over 4, I'm going to be at 2. At 0, I'm going to be at negative 1. At pi over 4, I'm going to be at negative 4. And at pi over 2, I'm going to be at negative 1. And we're just going to graph one period. So this graph would keep repeating itself over and over and over. For this graph, what is the amplitude? 3 is the amplitude. It's the number that's out in front, guys, that A value. The period is how long it takes for it to make one of these cycles before it starts repeating over again. How far is it from negative pi over 2 to positive pi over 2? Pi. Here's the other way to find the period, guys, right here. 2 pi over b. 2 pi over, what is the b value? 2. Doesn't that make sense? It's pi. That midline is literally the middle horizontal line that goes right through all these points. It's also y equals k. What is the equation of this midline here? Good. The domain is the x values we can use for this. We can use anything. So it's negative infinity to infinity. The range is our lowest point up to our highest point. What's that going to be? Good. Now, if you want to follow along, you can, or you can just watch, because you should check things like this. If this is on the calculator part of the test, I'm definitely going to check my 5 key points if I have time. Sometimes we don't. And guys, one of the things that people have trouble with on this is just typing it in correctly. And I'm going to talk about that here. So what's happening is the sine of 2 parentheses x plus pi over 2. So you really have to have parentheses around this whole angle. Otherwise, it's just going to take the sine of 2. It's going to treat it as 2 radians, and that's not what we want. Okay, so I'm going to do a zoom 7. I'm going to take a look at it. Looks pretty good. But I also need to look at those 5 key points. Now, when I go to this table at the beginning, This table is probably not going to be set up right. See how I'm not seeing the points that I expect to see? Okay, now watch this closely, everybody. I'm going to go to my table setup. Where is my table starting? What x value? So I have to put in negative pi over 2. That's where I'm starting. How much am I adding on every time? Here's the easiest place to see it. What is it? Pi over 4. So I'm going to put that in as my delta table. Now I'm going to go back and look. Negative 1, 2, negative 1, negative 4. See how we can check it so easily? And now we know that we have the correct 5 key points. Okay? All right. Do you guys feel like you can do this on your own, or do you want to do it? Lots of no's. Okay. If you feel like you can do it on your own, you should go for it. And I'm going to talk through the other people who would rather just go through it together. All right. So if those of us who are doing it together, let's actually answer these questions first. Okay. The amplitude is the absolute value of whatever number's out in front. What's that going to be then? 1. The period is always going to be 2 pi divided by b. What's b in this case? 1/2. What is 2 pi divided by 1/2? What is it? I have to multiply by the reciprocal. So it's going to be 4 pi is going to be the period. I have to multiply by the reciprocal. Or back here, I could have noticed just multiply this by 2 and this by 2. All right. The equation of the midline, if I just look at this, I should be able to see what that midline is going to be. It's always just this value here, this d value or this k value, depending on which way we want to think of the formula. So what's the equation of the midline going to be? Y equals 3. I'm going to go ahead and put that in there. It just helps us when we go to graph. The domain we already know. Range, I don't know that yet. I have to graph first to know that. Okay, so we're now going to put down our 5 key points. Now, this is sine again. I kind of wish I would have made it cosine, but it's sine, so let's keep it as sine. But what if it had been cosine? Do you guys remember the 5 key points for cosine, how the y values go? What are they? Okay, but it's sine, so we're going to keep it that way. So our x's, we always use those quadrantals. It's just the easiest 5 key points to get. Okay, so our y values for sine, tell me again what they are. Yes. Okay, I always like to do the y's first. I think it's easiest. So we look at our multiplier first. Multiplication comes before addition and subtraction. So what's our multiplier? -1. Okay, what's this plus 3 going to do? Shift us what? So add 3. Oops, that's not right. -1 plus 3 is 2. Okay, there we go. All right, let's talk about x's now. We always want to look at the multiplier first because multiplication comes first. Am I going to multiply my x's by 1/2 or by 2? 2, because this is actually going to be a horizontal stretch. With the x's, it's the opposite. So I have to multiply all of my x's by 2. Okay, so let's see what we've taken care of. We've done this, and we just did that. So the last thing we have to do is any shift left or right. And so what are we going to do? Shift right pi or left pi? Left pi. So I'm going to have to subtract pi. 0 minus pi. All right, and so now we will plot our points. So, oh, this is hard to see. Negative pi is right here. I'm going to be at 3. At 0, I'm going to be at 2. At pi, we're going to be at 3. At 2 pi, I'm going to be at 4. And at 3 pi, we're going to be at 3. And we're just going to graph one period of it. Oops, you guys can't see any of that. And so that would be one period of it, and then it would keep on going. Those of you who did it on your own, did you get the same answer? Okay, so we won't bother checking it on the calculator. All right, any questions? It's kind of nice because these rules are the same as the rules we've been doing all along. It's just with a more complicated looking function. All right. Okay, we will stop right there. Oh, the range. Let's go ahead and do the range real quick. What's our lowest point, you guys? Up to 4. So 2 to 4 would be the range.